section 2.10 functions. In this video, we'll talk about what is a function, and we'll talk about defining a function, talk about function arguments, return values, variable scope, and finally we'll talk about call by value versus call by reference. So what is a function? A function is a subsection of a program that performs a specific task. It's a block of code. A program has at least one function, and that function is called main. Functions other than main are not executed until they are called. Those functions other than main are called from main, and they could also be called from other functions. To create and use a function, we need to define few parameters. First, we need to define the type of return value, if any. This return value can be the result of calculations. This return value is returned to the caller. So if the function was called from main, the return value returns to main. Second, we need to give the function a meaningful name. Usually it's related to the task it's performing. The name is followed by brackets. Inside the brackets, we define function arguments. Function arguments are variables that the function needs to perform its task. These variables are passed to the function by the caller. So if the function was called by main, main would pass variables to the functions in order for it to perform its task. As an example, if we wanted to define a function that adds customer info to a database using their name and telephone number, we could do the following. We first define the return value type. In this case, I said void to indicate that there is no return value. Then, I gave the function a meaningful name, add_customer, because that's what the function does. And finally, the name is followed by brackets, and inside the brackets I said that this function will accept an array of 20 characters, name, as well as an integer, tel_num. Let's do an example. This is example 2.10.1. In this example, let's define a function, and let's call this function add_nums. This function should accept two integers, a and b. This function should also return an integer, which is the sum of a and b, to the caller. In main, let's declare three integers, num1, num2, and result. Let's also assign the value 3 to both num1 and num2. Let's also call the function add_nums from main, and let's pass add_nums, let's pass it the variables num1 and num2. Then let's store the return value that's coming from add_nums in result. And finally, let's display the value stored in result on the screen. We should expect this value to be 6. Now please open the file example-2-10-1.c in code blocks. Okay, so once you open the file, this is the code that you will see, and you will notice a few things. First, on line 3, we have what's called a function prototype. A Function prototype is a definition of a function that does not include the function contents. It does not include the code that goes inside that function. It's just a definition. So we're defining a function called add_nums, and we're saying that it returns an integer and that it also accepts two integers. We did not give those two integers any name. We're just saying that it accepts two integers. And then we have two functions, function main and function add_nums. Function main declares three variables, num1, and we assign it the value 3, num2, which also gets assigned the value 3, and result. On line 11, we say that result equals, and instead of assigning a value to result, we call the function add_nums. We do that by typing the function name and passing appropriate arguments to that function. In other words, we have to pass two integers to add_nums. So we pass the value of num1 and the value of num2, which is 3 and 3. At this point, I should mention that if we did not have a function prototype for add_nums on line 3, function main would not recognize this function, or the fact that it accepts two integers. That's because the C language is a structured language, and the code gets executed from top to bottom. And since the function add_nums is written after main, calling the function at this point without a function prototype declaring add_nums would be problematic. Going back to our code. When we call the function add_nums on line 11, this will initiate the execution of that function. And so we jump from line 11 to line 18 here. And the value of num1 gets assigned to the variable a, and the value of num2 gets assigned to the variable b. And then going into the function body, there is only one line that will be executed. Don't worry about the commented out code for now. So the one line says return a plus b. So it will return the sum of a plus b. In other words, 3 plus 3. It will return the value 6. This value will be returned to the same point where the function was called from. So we go back to line 11, and the value 6 gets assigned to result. Then on line 13, we use the printf function to print the value of result. So the sentence or the message will say the result is, and the %d, which is a placeholder for integers, gets replaced with the value of result. So let's compile and run this code. We'll go to build, check our messages, log messages, all looks good. Let's run the code. And the message says the result is 6, as expected. Now let's go back to the slides. Next is variable scope. A variable scope is the region where the variable is recognized. We have two types of variables, global variables and local variables. Global variables are recognized and can be used by all functions. Local variables, on the other hand, are only recognized in the function where it was defined or declared, and they cannot be used by other functions. Let's go back to our example in code blocks. Let's go to lines 20 and 21, and let's include the commented out code by removing the double slash from each line. On those two lines, we are trying to assign the value 5 to num1 and num2. Num1 and num2 were declared in the function main. If we try to compile this code, we should expect an error. Like I said in the slides, variables that were declared inside the function are local to that function and cannot be accessed by other functions. So let's try to compile this code. We're going to come to build, and sure enough, we have two errors. And if we read the error messages, the error message says that num1 is undeclared. Same thing for num2. Num2 is undeclared. That's because we're trying to use num1 and num2 inside function addNums, but they were not declared in this function. They were declared in main. On line 11, we were only passing the value of num1 and the value of num2 to function addNums. These two values were stored in the variable a and the variable b, respectively. This is called passing arguments by value. We are only passing the value of num1 and num2 to this function, addNums. Now let's go back to the slides. The last thing we will talk about for this video is call by value versus call by reference. When calling a function, we can pass the arguments or the variables it needs in two ways. We can pass the value stored in those variables, or we can pass a reference to those values or to those variables. In other words, we can pass the address in memory where those variables are stored. However, to pass addresses to a function's arguments, these arguments must be capable of storing memory addresses. In other words, they must be pointers. Let's go back to our example in code blocks. So in this code, num1 and num2 were declared in main. We cannot directly change them as we tried to do here because they are local to main. We can, however, pass the addresses of num1 and num2 to addNums. We will need to do some modification to this code. We will first need to change the two arguments of addNums from integers to pointers to integers. And we do that by adding a star after the type int. So we're going to add a star here and a star here, and we have to do the same for the function prototype. So we're going to add a star here and a star here. Now we are saying that addNums accepts two arguments. Those two arguments are a pointer to an integer and a second pointer to an integer. We also have to change line 20 and 21 to say star A equals 5 and star B equals 5. We are using the star, which is the dereferencing operator, to access the memory addresses that A and B are pointing to. We also have to do the same for line 23. We need to add a star in front of A and a star in front of B to access the values stored in the memory addresses that A and B are pointing to. Those values are added and the result is returned to the caller right here. and that result will be saved or will be stored in the variable result. Next, we will add the ampersand operator in front of num1 and num2 to indicate that we are passing the addresses of num1 and num2, not the values stored in them. Finally, let's add a printf statement on line 14 to display the values of num1 and num2. Now let's compile and run this code. All seems to be okay. Let's run the code. Let's bring the window down here. Even though we started with num1 and num2 having the values 3 and 3, now we can see that the printf statement from line 11 is displaying the message the result is 10. And the printf statement on line 14 is displaying the message num1 is 5 and num2 is 5. That's because we accessed the addresses of num1 and num2 using A and B, and we changed those values from 3 and 3 to 5 and 5. Let's go back to the slides. And that's the end of this video. Next is section 2.11, structures.